Hello, hello. We're about to begin. Please take a seat. Hello, we're about to start. Please take a seat. Yeah, pass me my beer. There's a acai at the back. Hi. Thank you all for coming tonight. Please take a seat. There's a few latecomers. We're going to wait us a minute. I hope you all enjoyed the cold pizza. All right, so welcome to Melbourne CocoaHeads 128. Yeah, we got a pretty good show up. I'm pretty happy for a rainy month of August. So thank you for coming. On the program tonight, we have some really good stuff. We have a really packed program, so we're gonna really go fast. Let's see when that thing stops animating. There you go. So we're gonna start with the intro. Hopefully, I'm go fast enough that we don't spend too much time on it. Our first presentation will be Jason Chan talking about reactive clean architecture. Second presentation right after that will be Matt Delves drawing graphs and adventure story in Swift UI. Then we're going to have a little break so that people can ask questions and get another drink and all that. And then the final presentation will be Kevin O'Neill, which will talk about Swift UI, or at least his approach to make Redux work with Swift UI, I think. Where is Kevin? I don't see him in the room. Anyway. And then, yeah, after that, we'll have question time, and obviously, for some of us, we'll move to the Irish Times to get more drinks. Let's talk quickly about the upcoming events after that. So first is going to be the Hack Night next week. No, actually, not next week. For some reason, it's a week after. It's going to be on the 21st of August. And it's at Cognizant, like always. It's just on the street, one block down, so it's really close and convenient from here. Drinks Night is going to be on the 27th of August at the usual place, which is the Imperial Hotel at the corner of Burke and Spring, I believe. Maybe, okay. Well, you will confirm that on Meetup, I'm sure. And 2nd September will be NS breakfast at Person and Murphy's on Latrobe Street. Please note that apparently there's no GTG meetup this month. I think they're taking a break for this month, so there's no GTG meetup. And then the next meetup is going to be on the 12th of September, the second Thursday of the month, like usual. That's going to be CocoaHeads 129. Another event coming up is actually that DevWorld is taking place next month in Melbourne. So our very own Swift and iOS conference is taking place. They announced that they have early bird tickets on sale, and I think they stopped that tomorrow. So if you intend on going, then you have 24 hours to still buy your ticket at the early bird prices. But yeah, great conference. I've never been, but I heard some good things, and I'm a bit biased because I'm going to speak at it this year. So get your tickets. Major sponsor for tonight is Cognizant. So we thank them for paying for the pizza, for the beers, and all of that. And our silver sponsors are, I think it's Domestic Cat Software, ADB Apps, and Latitude Financial Services. So thanks to them, because that's thanks to them that we can have this event. Our new sponsor is YBF. So for like the last couple of years, we've been here, and it's a great venue. So thanks to them for hosting us and accepting us. Tolerating us, I would say. The code of conduct of CocoaHeads. So to remind everybody that our community is dedicated to providing an inclusive environment for everyone, regardless of gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion, or lack thereof, or technology choices. It's on the website, and if you feel like something is not right, either tonight or at another event, then you can submit feedback at these addresses, and you can do that anonymously, and a bunch of us will basically take care of it and at least analyze what you have said to us. About questions, to reiterate from last month, we're trying something new now for the last couple of months. We're not doing any questions during or at the end of the presentation. It helps with the flow of the night. So it's going to be offline during the break after people present. It makes it easier on the speaker. It makes the evening flow better. And yeah, we'll gather more feedback maybe next month. So let us know whether that works better for you or not. We got some good feedback last month, so we're going to try again this month. Again, CocoaHeads as a new structure for the last few months, since Jesse is taking a leave of absence because of babies, I guess. When you have a baby, you disappear. And so the new structure is that there is no more benevolent dictator. So we thank a lot Jesse for his contributions over the years, but we're going to try to have like a group of people that take care of CocoaHeads nowadays. There's a bigger team, smaller roles. We have a dedicated team to reach out to students and juniors, so thanks to them for actually like going out and trying to advertise that we are a community that exists, because apparently a lot of newcomers to the community don't even know that CocoaHeads is a thing that exists and they can come to. And yeah, like we are rotating event-based team. There's more people involved. And for example, last month was Jet organizing CocoaHeads. This month it's me. Next month is going to be you on your right here. So yeah, we're rotating the organizers every month. So every month is going to be a bit different. We're always looking for more volunteers. So if you want to volunteer, you can help with the meetup page. You can open up pull request to the website. You can also be a MC. You can totally just be a MC if you're willing to try. You can be a mentor for people that want to speak, and you can help with the setup of the room if you come early enough, and you can help us set up the tables and the chairs. There's a lot to do actually every day, every month. For volunteers, join us on Slack. Obviously, there's a channel for that. And I just want to thank everybody that volunteered for tonight. So that's me on the top left. That's organizing mainly. You is the second organizer for this month. Ronak was the third wheel. I don't know if he's around this room. Thank you to Nabila and June for taking care of a lot of things, including ordering the beers and drinks and being at the entrance for everybody to get the stickers. And Harry as well, that showed up fairly early to help with his hands. And also somebody is not on the slides, but I want to thank also Rob, who is there every month to help with the audio setup and to fight all the gears and to make sure that everything runs smoothly. So you're not on the slide, but thank you, Rob. And I know you might not be as around later, so just a big thank you from everybody about that. Yep. We're always looking for speakers as well, so if you have a presentation, you want to talk about anything from a really simple subject or something fairly advanced, then you're welcome to submit a presentation at any time. We have a channel on Slack for that, but you can also submit it on the form on the website, and we will basically try to schedule you as conveniently as possible. So please, if you have something to speak about, we would love to hear from you. For juniors that want to speak, they are very welcome. Same thing, join us on Slack. And we are trying to get a reserve slot for juniors every month so that you don't feel like you're imposing yourself, right? We're really willing to hear from you and to, like, in a way, we're all juniors because of Swift UI. So if you are doing anything new with iOS 13, then you're welcome to talk about it because none of us know what we're doing. So don't be intimidated. We're all trying to figure it out together. And we also provide mentorship to people. So if you don't really know how to set up your slides or to speak in public, then some people can help you really iron that out before you come on stage here. Anyway, so let's talk about if anybody has shipped anything, if you shipped an app or anything interesting. We want to hear from you. So did anybody ship anything last month? Okay. What is Reveal? No, so Tony Arnold shipped Reveal 24. Is that what you say? Yeah, I also ship that, so I'm part of that, but I'm biased, so I can't.
The latest version of Reveal, which if you don't know is a view inspection tool, revealapp.com. I think Reveal 24 has iOS 13 support for some UIKit new properties and additions. Carlos here worked on the design. Renault worked on which parts? Could you? Right. Yep. So there's more to come as well.
Thank you. Anybody else? Shifting. Okay. Rob is coming for you.
I built a app called the Ginners for my social netball team, and it uses Spike Kit and some cool seeing kit things to like bounce around balls that you've got to catch. It was just a lot of fun to build, but it doesn't really work on iOS 13. So if you've got beta, maybe hold off until I can give it a few more releases. But I had a lot of fun building it.
Yeah. Feel free to link to it on the Slack channel, and people will check it out. Anybody else? No? Okay. Well, it's winter after all. Okay. Oh, I forgot the animation, so now we have to wait for the animation to finish. There you go. Okay. Anybody's hiring or looking for work right now? Now is your time.
I'm oddly looking for work.
And his name is Kevin, and he's going to talk later tonight, so you'll know who it is then.
Hello, I'm one of the mobile engineers from Redbubble. So our summer internship program is going to kick off. So we are looking for one iOS intern and an Android intern on the team. So our office is located in the CBD on Collins Street. If you are interested or know someone who is interested, please reach out to me. Thanks.
All good? Anybody else? Okay.
Hey everyone, I'm Matt, one of the many Matts here. I am looking for some contract work. Got some availability starting pretty soon, so yeah, get in touch.
Thank you, Matt. Okay. Last final call. Okay, done. All right. And once again, I forgot the animation, so we're going to admire that animation from Jet that he designed last month. And yeah, if you still have something to offer, then don't forget to post on hash jobs on Slack. It's a good channel for that. Now, before we move on to presentations, I have one last thing to talk about, which is this idea I had now for the last couple of months, which is that we use the same CocoaHeads logo that the whole world uses for the last for the last few years. And I was wondering if maybe there was a potential to customize the CocoaHeads logo for this community. So I've seen some CocoaHeads chapters around the world kind of do that, and so I was like, maybe we can have that. So I offered a challenge to some people to refresh the logo of CocoaHeads Melbourne, and Carlos, who is where is Carlos? Took up the challenge, and I'm going to come right to that, but he took on the challenge to do that. But before that, I want to talk about Sean, who was the main organizer of CocoaHeads a few years back, had the same idea actually, and posted on 99 Design basically a contest to redesign a fresh, vibrant, modern, whatever you want to think about, logo for CocoaHeads. And what he got was, as a number one result, was this. And that looks pretty fresh, but at the same time, it looks more like a Space Force medallion than something for a community. And also, exactly, it does look like a butt, and as soon as you notice that, you can't unsee it. So it looks great, but it wasn't used in the end. And that's why we didn't use it, but that was a logo that was almost used since a few years ago. So it ended up being used, and we've used the Coco Mug guy for a long time. But I basically asked the people, like, if we really want to do something specific to that community, then what's intrinsically Melbourneian? What it defines this city, what is specific about this city. That's also a CocoaHeads chapter in Sydney. So we really want to do, not to do something about Australia, but about this city. And so I'm asking you right now in the audience, what's intrinsically Melbourneian? What would you say is intrinsic? Coffee? Anything else? Yes, the rain, but so does 90% of the planet as well. But trams, yeah, that's pretty good. But yeah, actually, like Jason, you spoiled it because you said coffee, and I think that, yeah, coffee defines Melbourne in a specific way because Melbourneians are very specific about their coffee, very, very serious. And so Carlos had the idea of, what if we took the cocoa mug guy and combined it with our own flat white, which, as far as I understand, is something very specific to Melbourne. So what if we combine these two? And what we got was this. So be ready for the reveal. Yeah, coming? Huh? Wait. Oh, come on. There's a video that's supposed to be playing right now, and it's not. Sorry, it's what? It's so minimalist. Yeah, it's a flat white, it's white. God damn. Oh, it's not loaded on your. Okay. Oh dear. Yep. Okay. Oh my God. Let me see if I can get it from Slack quickly, and I'm gonna go. And it's gonna be a one big reveal all at once. It's too bad it was nicely drawn by Carlos. Let's see, Carlos. Sorry guys, I just need to find the picture again. It was on my laptop, which is here, but not on Yu's laptop, which I'm using for the presentation, which is why it went all wrong. And here it is, almost screen. And here it goes, there you go. Yeah, please clap. So you see right now it's a CocoaHeads mug logo, but as a flat white, and I think it's super cute. I think it's great. It retains the quirkiness of the original. Yes. Yep. Let's see if I can make it go landscape. There you go. It retains the quirkiness of the original logo, but also giving it a twist based on Melbourne. And so I hope that it will become in the future our very own logo for CocoaHeads. And I don't want to impose it to anybody, but I was thinking that maybe we should use it for like a month, and maybe in a month we'll have a poll on Slack to find out if we really want to keep that or maybe go back to the other. But I want to put it to the community. So let's use it for a month and let's see what people think after a month. But personally, I love it. So we're going to try it. So you might see that becoming the logo for the next month or so on different CocoaHeads resources. Anyway, now it's time for the presentation. Jason, you're up on stage. So Jason, about himself, he told me that he's a mixologist wannabe and a third-party proclaimed foodie. I don't know what that means, but that's what he told me to say. Fun fact, he integrated iPads with a thermal receipt printer in a room surrounded by 30+ iPads. That's a fun fact.
Hey everyone. See if it works. Cool. I hope everyone's comfortable. There's pizza digesting in your tummies happily, beer in a hand, or beverage of choice, who am I to judge? So since this is my first time speaking here, I'd love to share with you all the journey at my current company, with a focus specifically on architecture. So let's see if this clicker works here. All right. Before we start, I would like to say, all software has an architecture. However, the design and planning within it is completely up to each team. And I'm not standing here to encourage anyone to convert their project to our architecture or any architecture for that matter. Nor am I here to say that one kind of implementation is the way to go. So with that out of the way, let's start off with some questions that I frequently ask myself. So if you are, what does building scalable and maintainable software look like? And as you work on a project long enough, you tend to have all these kind of questions like, how do I scale up? How do I modify and extend my current features? Things like that. How do I know I'm building something the right way? Is it like a gut feeling? I don't know, maybe it's just me. I walked into a really messy code base. Ooh, now what? I walked into an overly engineered code base. Now what? So if you ask Google, depending on your choice of words related to architecture, you will get a multitude of different ideas on how to implement stuff and how things should work. So I hope that we can all use this talk to really distill what I would call the essence of what is good in them. So with that said, hi, my name is Jason. This is me 3 years ago at Silicon Valley. This is a beverage of choice. I love ale, especially red ale. If you love ale, hit me up, we get ale. Love that stuff. And this is my wife and cat. I work at Punters. We deliver racing stats and form data to the everyday punter. Our feature set includes tons of awesome stuff like news, forum, live chat, just for everyone to, and all with the aim to make horse racing more awesome. So let's talk about the iOS app. So the journey here started in mid-2014 in Objective-C, and that was the standard at the time. And then the developer at the time saw that Swift was kind of up and coming, and I think it was Swift 2.0 at the time, and he started rewriting tons of classes in Swift, and that was the end of 2015. And I joined mid-2016 and continued writing Swift, and sometime in the previous few months, we completely moved everything from Objective-C to Swift, native, of course, excluding third-party dependencies. Let's talk about the architecture journey now. So, MVC, as prescribed by Apple, and that's how everyone started at some point. In 2014, moved to MVVM in 2016, and that was around where I joined. And we did MVVM a little without the use of bindings, because we didn't really have a reactive framework or anything that could bind objects together. So we sort of winged it ad hoc a little bit, and then we started to go on this journey to a new architecture called Nemo. And Nemo was the team's attempt to find commonalities in our daily programming tasks and make a pattern out of them. And that was also about the time where we introduced the Reactive X, aka RX Swift, particularly in our case, into our app to improve communication across the objects. So, of course, and then in mid-2018, we moved on to our current architecture. So before we get to that, let's look a little bit at Nemo. So Nemo stands for Neat Modular. And without getting into a lot of detail, we start off with an ID, and we inject that into something called a controller. And this controller is something that controls like a view controller or a cell controller, what have you. And this controller is essentially a black box. It would then go and create something called a data source, which then creates a model. And then this model is used to bind one-on-one with the view. So the controller would give the ID to the data source, and the data source would do the fetching. It would do all sorts of fetching there, and then actually create the model itself. And then the controller would go, hey, view, prepare your view with data source.model and properties. So Obviously, now there are a lot more layers here in a vertical slice. So there were some advantages to it, like introducing a pattern to follow, because we really, at the time, needed some kind of pattern and stick to it, because there was just a lot of ambiguity around how to just write good code. And then obviously distributing code into different sort of neat modules made it a little bit better, a little bit more testable, but there were quite a few problems as well. And these problems came up more and more as we started to get more developers in and extend our feature set, basically. So I looked back and I decided to categorize all the pain points into something like this, a table of solid principles. Who here knows solid? Anyone? Who here practices solid? Okay. Solid principles are just a really good way of ensuring that your app ticks all the boxes in terms of scaling, maintainability, just good coding practices in general. And I won't get into the detail of it, but let's just look at the pain points here. So single responsibility principle. An object shouldn't change for more than one reason. And an object should do something, one thing and one thing well. So most objects in Nemo were small, but our data source objects tend to know too much. They knew about fetching, how to fetch things from the API, model creation. It even created the model itself. And then some UI code actually leaked into there. So there was UI kit knowledge inside that data source for some reason. So that just violates single responsibility straight up. Open-close principle. An object is open for extension, but closed for modification. So what that means here is models were coupled to the UI. Like you would go label.attributed text equals model.label attributed text or something like that. So it was a direct one-to-one with with the views. So you wouldn't really be able to extend anything from this model. You would just end up creating a new one. And same with Liskov substitution principle. This is just inheritance, kind of substituting an object. So let's try it, right? So this is off the top of my head. I'm actually just recalling this from memory. So you have an object, and this object depends on another object that has a subclass. So you can just substitute that subclass in, and that object should compile and just use that subclass just exactly how it thinks it is for the original one. So if that makes sense. So again, in Nemo, all our stuff in that vertical slice were highly specific. So you would really never subclass anything. You would just, let's just make a new Nemo stack, and so on and so forth. And interface segregation principle states that, so what would that state? So it's basically you would objects should depend on things that they use, and you shouldn't depend on things they don't need, putting it the other way around. So there were no interfaces within that vertical. Controllers had to actually access the model to prepare the view via the data source, which just reached into the guts of all the implementation. And you would never be able to cleanly make a cut and replace things without changing a ton of implementation. So it was just totally violating this principle. And then the last one, dependency inversion. Objects should depend on abstractions and not concretions. So the controllers and data sources create the things that they depend on. What that means is you wouldn't be able to, you basically, each object just knew too much about some kind of detail. So only the model could truly be isolated because it got injected with an entity. Everything else was pretty much untestable, or parts of it were, and we just had to ignore the rest of it. So was Nemo solid? Probably not. It worked okay for a small team at the time. We wanted to follow some kind of pattern to be unified and working towards the same goal, but it doesn't really scale and meet our requirements. And we always think of software being modular. We want to just make it and arrange it the same way, but that generally never happens. It usually is something like this, where you have to think about how each feature or functionality would fit into your application, and have to deal with all these different conflicts, right? So we need to pay a lot more attention to software design here to be able to scale up. And this is about the time when I was reading this book written by Robert Martin called Clean Architecture. And a lot of people would have seen this diagram somewhere in the web. So this diagram is a very, very old diagram on how Uncle Bob, that's what we call him, Uncle Bob decides to sort of distribute the software applications or things in different layers. So to set some context, let's just quickly go through this. So we have the entity in the middle. An entity represents objects in real life. They don't really rely on anything because it makes sense for these objects to exist. And that's how we would represent them. Use cases, which is the red layer, the red circle there, are the business logic and where the company defines value of the features. Then the controllers and presenters in that green ring over there would take these use case objects that are related to the business and then make that output to the view, however necessary. And the outermost layer is what we call the foundational layer. I think that's what I call it. And then where things are sort of more concrete and platform specific. For example, you'll have like things like the web, UI kit, some kind of database implementation, or external interfaces or libraries that we need to actually present our data to the user and actually get it into their hands. So that sort of stuff is really, really concrete, right? And of course, the arrows that we see pointing from the outermost to innermost is where the dependencies lie. So entities don't really depend on anything. And the foundational layer sort of is everything. So think of it as the most concrete to the most abstract, most dependencies to least dependencies, most likely to change, least likely to change. And we should be thinking of it in that way. I'll expand on that a little bit more later. So how does clean architecture, and all this was sort of built on the web, right? So this sort of diagrams were all, I think his book is all basically in Java, most of it. And then all this was sort of web understanding. So how does that translate to us in iOS, right? So let's start off with a simple scenario. We have a view controller here, and this view controller needs to request some data, and then save it to the database, and then display it back to its view. So it knows about some kind of URL requesting, some sort of core data, which is like a database. And for comparison purposes, I've set them as blue, because blue is the foundational layer. And these objects rely on specific frameworks like UIKit, core data, could be even RealmDB, or AF networking, LMOfire, you name it. So what I would do is split any kind of business logic into something called an interactor, or we could call it a use case. Uncle Bob uses that term a lot, use case. And then that would be all this sort of business logic that doesn't really have anything to do with the view. But then there's also a lot of presentation logic, right? Because these objects in the web could be quite structured and hierarchical. So views like something more consumable and flat. So that's where we have a presenter. And the presenter would take care of any kind of business logic and transform that into something more presentable to the view. And then those two, core data and requests, we can just categorize them as fetcher, because that's just how we can name it. It's just something that understands how to fetch things or deal with the details of stuff. So if we look at the two objects in the middle, the use case deals with business rules and logic, and you should want to test that a lot. The presenter has obviously presentation logic, a lot of transformation logic to the view, and we should also be able to test that. And let's talk about how things communicate, like how each object communicates to one another. So we start off with the entity. So we call, obviously, using the same colors, the entity is the sort of domain objects that don't have dependencies, right? So the fetcher and interactor mainly deal with those. So the interactor would then pass that to the presenter, or depending on the case, it may create something called a data model. And then this data model would still would basically just represent the use case for whatever it needs. And the presenter would take that and transform it into something called a view model. And that's how we're sort of currently looking at these different transformations. So someone that does Viper might say that this looks pretty much exactly like Viper. And also note my talk covers Viper things, but minus the router, because this 30 minutes is just not enough to talk about clean architecture and routing. So yeah, we're just gonna cover the clean architecture part. So what we do at Puntus is we really love Swift. So we take a very, very Swifty mindset and then apply that to a clean architecture principle like Viper, implementation like Viper. And then we also have RX. So we combine that, and what we get is ViperX. So let's look at a common scenario of Viper. So let's look at this scenario where we just want to fetch and display something from an entity. So we get an entity and we just want to output that directly to the view. Very, very simple. It's just a read-only screen. So what we do for Viper, if we're going to implement Viper, would be we have a presenter input protocol or interface, whichever you like to call that. And the presenter would implement it or conform to it. The view controller would then use that, hang a dependency on that to ask it to load or ask it to do stuff. And then the presenter would then use an output protocol that's implemented by the view controller to send it the view models or the data that's necessary. Make sense? So same with the fetcher. The fetcher has an input protocol that it conforms to. The presenter uses that to ask it to fetch stuff. And the presenter conforms to an output, a fetcher output, that the fetcher uses to send the data back. And this is a traditional delegation pattern where there are no bindings, there's just basically function calls. And we usually have this kind of one-way, single-directional data flow because the calls are asynchronous, most likely, and we want to split the inputs from the outputs. So how would we improve this in using a bit more reactive way? So what we do is we combine the input and output protocols into something called presenting. And we also do the same with fetching. So there's an input and an output, but now they're the same thing. But we still want it to be a single directional data flow. So how do we really do that? Which brings me to a little bit of code here. So let's dive into it. So on the top, we have a race event, a basic race. So thinking about horse racing here. So it's a race that happens, and we want to display the horses that run in a screen. So down there, you have runners. And the runner has some details and stats about it, like name, jockey, trainer, and the number of it. So that's just the entity. As you can see, it basically just imports foundation. There is no fancy things here. They're all just humble objects that are as primitive as possible. And obviously, we use decodable because that's just simple to do. Moving on to the view model, which gets more interesting. So we're talking about the data here, right? Just data are humble objects that gets passed along. So view models are a bit more flat, like this. So you have race event view model, which is the top one. Then that has a title and it houses the runner view model. So runner view model is at the bottom there. You'll have title, jockey, trainer, and all those are just strings and some stats. And then we have something called odds, which is an observable of type string. So odds in our context is something like prices, and prices change over time. Like odds change all the time, they fluctuate. So how do we model that in a reactive way? So that's why we have a string, which is what we want to display as an observable, and an observable is something that can send events across time, a stream of events across time. So that's exactly what it is. We also have something called select. That's interesting. Never seen that one. As a type any observer. and it is of type void. So, and any observer is an Rx object that you can push events to or trigger events, and that will send on next signals along. I'm not sure how many people are doing Rx, but they're basically just using observer patterns, observer and observable. These two are just hand in hand. So one is like read, one is write. So, and we have a dispose back there that handles, takes care of the bindings. So by declaring that this view model has a dispose bag, it means that this view model is responsible for the lifetime of the Rx event streams. So that means when the view model is destroyed, all these bindings would disappear as well and get cleaned up. So let's dive into the presenter here and look at the protocols. So the presenting protocol is simple. It has a view model, which is an observable, and a load function, which it relies on something to tell it to load. The race event fetching, see how basically the syntax would be the feature name and then the object itself or the interface. So race event fetching would have race as a single and odds for some kind of runner ID. So you give it a runner ID, it should give you back an observable of type double, and then that would actually, you would be able to bind to that. So what the presenter is initialized with is a fetcher. So a fetcher is some object that you implement, which is when you implement the fetching protocol. So this fetching protocol, the fetching implementation could be literally anything. It could be from a database, it could be from an API. It's really up to you how you would implement that. All you have to do is make sure that you would conform to race and odds. And the presenter itself would load in this way. So it would have the load function and ask the fetcher for the race. It would then create a view model from it and then bind it to something called a sync, which is basically just some kind of state, a reactive state that we have inside the presenter. So this is literally how we would code, or a pattern that we would code inside the presenter. And then the view model is just a wrapper, so that's a computed property in Swift, and that would wrap the sync and just filter nil, because we do not want to send nil view models to anywhere else, to the view. So let's actually look at making those view models. The top one is basic. We don't want to go through that. It's just a bunch of formatting with the race. So you just take a race and you format that, and then you take those runners, and for each one you map into a runner view model. And the runner view model is where the reactive stuff comes in. So you have your select, which is a published subject in here. So a published subject can be an observer and an observable. So it can actually be both. So, and it's of type void because we don't really need a type there. We just need to know that this view model got selected. So we subscribe, we want to handle the action of this select. Maybe we want to log some data or present a new screen. So this is where we do it in the subscribe on next. And that's also a potential place for router navigation, which I will not cover because there's just no time. And we would dispose it by the dispose bag that we create within this function. So it's all scoped within this function. There is no side effects. There is no self do anything besides maybe potentially some sort of delegate call for routers. And then looking at odds, the odds would just call the fetchers observable. So fetcher being the protocol, it doesn't actually know what object it is. It just asks for odds for this particular runner ID, and it will map it to a format, like a price format, a dollar format. And then this return would actually be the initialization where we do a bunch of formatting, and we pass the odds in as an observer. So it's actually an observer, and select is an observer. Sorry, odds is an observable, and select would be as an observer. And then we also pass the dispose back in because we want to make sure that we clean up after ourselves. So how do we use all of that? We just have a view controller that is injected with a presenter of some interface, which is presenting. And we have your view model, we have a table, and then we call presenter.viewModel get the runners from it in the subscribe block, and then we call reload data, table view.reload data. And what the data source actually is basically just getting a cell, preparing it with the view model that it has. So this is super basic table view code that everyone has written something like this at some point. And the interesting thing is the runner's odds will be bound to the cells button, dot title, and then disposed by the cells, disposed back for reuse. And then when you want to actually tap on that cell, you have a basic did select row at index path, and then you would just get that runner view model, add that index path, and then just say select. So basically, that's all you need to create a full flow from the entity to the view and back into a new screen. So to wrap up, the more dependencies an object has, the more likely it is to change. So we should think about coding in a way that reflects what is most important to our business. And how we do that is to use interfaces and protocols to guard and protect against any kind of change. So there is no one-size-fits-all. The earlier example I showed is the interactor being unnecessary because there's no business logic and it was only required to have presentation logic. So hence a more simplified version of the clean architecture. Conversely, I think we shouldn't limit ourselves to only those components. Feel free to have as many layers as necessary or as little as necessary that fits your needs, right? And of course, using reactive frameworks like I did in that example was really awesome, and it allowed us to eliminate a lot of boilerplate code that people would shy away from when implementing Viper. And yeah, just use it to supercharge all the interactions and have a unidirectional data flow. And again, clean architecture is not, any implementation of clean architecture is not really a silver bullet at all. But with these concepts, you would be able to go far and you can craft your own silver bullet. And that's really all I have. Since we're not having any questions, thank you all.
Next up is Matt. And for those that don't know him, Matt fell into the role of owning his own business just so he can spend time traveling the world and riding his road bike up mountains. He has a passion for creating apps that delight and amaze, and he's been learning Japanese for many years but never managed to pass a JLPT exam. Is that so, Matt?
Okay. While everyone is grabbing a drink, we might get started. So today I am going to be talking about drawing graphs with SwiftUI, and it is an adventure story. By that I mean I'm going to tell a story about how I took some existing functionality that was done using UIKit and translated across into SwiftUI, which is the whole new, awesome, funky stuff that we all love and enjoy. So, hi everyone, I'm Matt. I move around a lot. I'm now back in Melbourne for hopefully the next little while. I got back a week ago. If you don't know me, come say hi. I'm friendly, it's all good. A bit of a word of caution. So this particular talk was written with Swift, all of the fourth betas of iOS 13, Xcode 11, macOS Catalina Beta 4, so things may have changed. We are now on Beta 6. As well as that, this is the third time I've given this talk, so it is either going to be the absolute best version, or unfortunately it might be the worst version. We'll see. It's going to be fun. It's a story and it's an adventure. Now, any good story, we need to have a little bit of background, and that background is talking about two particular different styles of doing UI. That is, we're going to talk about declarative UI, which is the new fun Swift UI stuff, and we're also going to talk about imperative UI, being the older, well, it's still modern, it's still new, but it is a different style, and it's UIKit, it is AppKit. They're still really good, they're just two different styles of writing UI. So in order to explain this a bit better, I am stealing from the Matt that is up the back there, because he put it much, much better than I did in one of his blog posts. So declarative UI is you load your handlers and their conditions into the system before starting, and the system runs itself to completion, calling your handlers if their conditions are met at any point. So this is pretty much just two friends having a good conversation. They're talking about things. They're not sort of going through a checklist or anything like that. It's just good amounts of fun. The other one is imperative UI. So the other Matt puts it like this. You run the system to the next life cycle checkpoint, and then you read stage from the system, looking for specific conditions, running a code if one of the conditions are discovered. So here we've got a checklist, and then someone throws a tantrum and everything blows up. As we probably all know from dealing with UIKit and AppKit, this stuff happens from time to time. So let's get on with our story and meet our hero. And our hero is Swift UI. So what our hero here sets out to achieve, well, what we're wanting to do is we're wanting to be able to specify a UI that is in a declarative way, something that makes sense, something that is telling a story about how this interface should be described and built. And in this particular case, we are looking at drawing of a graph, which is pretty cool and pretty fun. So every hero then needs some friends. So the friends in this particular case are the basic types and building blocks that we are going to use in order to construct our graph. So we've got our view, which is the most basic and fundamental of them. We've got a shape, we've got a scroll view, and we've got a geometry reader. So let's have a look at how each of those is composed in order to create our graph. That one. So hey, technology with human interaction never works. Okay, so our view. Here we have an awesome view, and this view just does a very simple thing. It is saying, here is a bit of text. That text is everything is awesome. And we are saying the font of this text is a large title. Now, what we're not doing here is we're not doing things like, what's the frame of this particular text? What's the color or anything like that? We're just saying, hey, UI system, go ahead and render a bit of text onto the screen. Oh, really? As I said, this will be either the best presentation or the worst one. Yep. Fun times. Okay. Now, the other thing is I'm obviously using Catalina, and it is... No, we'll try mirroring displays. Nope. It's... Yeah. Being very specific of draw it, say, in the top left or anything like that. It's all very straightforward, all very nice and clean. The shape. So, as you know, with graphs, you need to draw fancy and pretty lines, and this is where shape comes in. So our shape, similar to what you're doing, you're just containing it within a particular type, and it all works really, really well. The next one is scroll view. So we all love the content size is correct, and we all know that it takes hours because there's a particular magic that you need to do and you always forget. With SwiftUI, we don't have to worry about that as much because SwiftUI is just taking care of it all for us. In SwiftUI, we are able to declare either a vertical scroll view, a horizontal scroll view, or one with both. And it works really, really well. No fancy constraints. It's all just straightforward. We're declaring something rather than trying to coerce the system into a particular state. It's awesome. I love it. Geometry reader. So with SwiftUI, the ideal scenario is when you have things sort of propagate out with their size. So you're not going to typically be setting a frame in the majority of circumstances. Sometimes you do. So sometimes, say, if you want to draw a very large thing, in our particular case of a graph, and draw that within a scroll view and other things, we need a little bit of help, and that help comes in the form of a geometry reader. What geometry reader allows us to do is take the sort of outside containing size and get the values from it. So here we are again setting some text, but with that text we are saying take the size of the parent and set the text's width to that. All very straightforward. Now, we've seen all of the friends, and we know that every hero needs her friends, because friends are awesome. So what we have here is the body of the graph. And we're going to just be piecing everything together with a little bit more fleshed out details. So what we've got here is, I'm leaving out some details, but you get the idea that we're just getting some points that relate to your graph values, and you're drawing them within a rectangle. You then have the axes which you need to draw, and in this case, again, it is making use of shape, and these shapes are just straight lines. The next one is the labels. These, so with this, probably one of the things I've omitted with the explanation from before is that there are 3 different types of stack you can use. You can lay out things vertically, which is a V stack, horizontally, which is an H stack, or you can lay them out arbitrarily, which is a Z stack. Here we are using the Z stack so that we can be a bit more specific of the labels and line them up. If you've done anything with SwiftUI, you probably know that using any view is like taking a sledgehammer. It's kind of bad, but it kind of works. So don't think this is the best code, it just works. Now, to put it all together, we end up with something like this, which is rather cool, rather amazing. And what we are doing here, my presenter notes have very small font. Hopefully everyone could read it at the back. Yeah, so we're just laying, yeah. That is very small font. I'm sorry. So we have the V stack there, laying things out top to bottom. At the top we've got the title, and then we've got an H stack, which is all of the stuff on the y-axis, being the labels and the lines, and then we've got everything else stretching out past the edge of that image, which is the graph data and the x-axis. So, moving on, all of this then fits within a scroll view, which is pretty cool and pretty amazing. So here we're again sort of cheating a little bit to define the content size. And the reason behind this is we need to specify the width of the graph. We have no way of sort of avoiding it. If we don't do that, we end up with a zero width graph, and yeah, no one wants that. Now, another cool thing we can do with SwiftUI is we can very easily tie in gestures, and in this particular case, we can tie in doing a sort of pinch to zoom or a scaling of the data. How we do it is we get a gesture recognizer, we just define some behavior on it, and then for our view, we say, just apply the gesture. I'm pretty sure this has changed with beta 5 and now with beta 6, so if Xcode complains that this is not the right way, follow Xcode. Xcode is right. I'm pretty sure this is out of date. So that's all good. Now, if we then wanted to modify the content, say applying a theme or changing the color or something like that, we can do that by just creating different functions or eventually get on to view modifiers. So in this case, we've got some data with our graph that is defining the color. And when we use the function fill on it, which I've defined here, we're applying a particular color. Here, we're applying the color pink because pink is awesome and the best color. Another way of doing this is we can use view modifiers. So view modifiers are really, really good if you want to do stuff like apply a fill, apply a shadow, do some other modifications and wrap it all up within a single modification. You would use this. So this allows you just to reuse them and apply them as needed. Cool. So that's all of the code. What are some challenges that I faced? One of the big ones is SwiftUI at the moment has been changing very rapidly, so you need to be across it. This is good in that we are getting a much, much better version of SwiftUI, but you need to be prepared to take on all of this extra work in order to make sure something is good and ready to be shipped. Another one is stuff like the scrolling, making sure all of the sizing is right there. That, again, was another change. Oh yes, one other important thing is if you've done macOS or AppKit development in the past, you would know that the coordinate system is based from the bottom left. In SwiftUI, it is always in the top left, as in it is the same as UIKit. That exists even on the Mac. So if you've got something that's across multiple targets, your coordinate system is always from the top left. I ran into it because I was adapting some code from AppKit. Yeah. Best practices still being fleshed out a fair bit. Apple's documentation is good. It's just still being worked on and still being developed. So anything you see outside of Apple's documentation is people's attempt at defining best practices. Whichever approach you want to take, just realize that there will be upsides and downsides to it. Cool. Some general advice. So with SwiftUI, the order in which you do things is important. So if you say, do a scale and then a shadow and then a padding, it is different from doing padding, then scale and shadow. So just be aware of that. Things are going to change. Again, that is something you need to be aware of. Overall, just tell the story of your UI. It is a very clear, very understandable, very descriptive way of presenting a UI. It has a lot of advancements, and I enjoy it and I love it. And I'm looking forward to seeing what everyone ends up building. So thanks. Do get in touch. Everywhere on the internet, I'm Matt Delves, and I need work.
We'll follow up with some question time, so you can take a break, get a drink, and we'll be back in 10-15 minutes.